negative. Again, I think just a couple of people got this one wrong. So let's have a look at that then. Hopefully the first thing you can see that the two diodes here are connected the opposite way around, so only one of them can in fact conduct, and if you remember, conventional current flows from positive to negative, so it will in fact be that diode that conducts, whereas that one won't, because the current is trying to force its way through the wrong way, as it were. So in which case we can therefore ignore this part of the circuit like so and just concentrate on the one on the top. So if you want to know the current through the battery I is equal to V over R. Well, the total resistance in our circuit is the 20 ohm and the 40 ohm connected in series, which of course is 60. So let's put that in there, so that's equal to V over 60. And he does say approximately, but it's a good bit of revision. Understand that when the diode is conducting, there's a voltage drop of around about 0.6 volts across it. So if there's 0.6 across the diode, the remaining 11.4 of the original 12 must go across our resistors. So we've got 11.4 over 60, which is, I believe, 0.19 amps, and the closest one, it does say approximately here, would therefore be B. Okay, moving on to the next one, question 6, probably the easiest question on the paper here, and yes, everyone got this, so I'll just very quickly talk through this rather than going through everything, working out, etc. Essentially, you've got to find the resistance. R is equal to V over I. It says we want to find the resistance when the voltage is 4, so it's 4 over, and then we have to go up and read off the current, which is 8 times 10 to the minus 3 amps, because it's 8 milliamps, and that will give us an answer of 500 ohms, which is answer A. Okay, very straightforward, that one. Okay, question 7 is one of the more difficult questions on the paper, I think. It requires you to make the link to resistivity and its formula. So if you can remember, formula for resistivity, we give it the symbol Greek letter rho. It's equal to RA over L. Now, this term resistance per unit length in the question is in fact R over L. So if we rearrange our equation, so it follows that R over L is equal to rho over A, then you should be able to see that R over L, the resistance per unit length, is in fact proportional to 1 over A. But of course our graph is related to the diameter and not the cross-sectional area, so we can therefore say that it's proportional to 1 over d squared, because of course cross-sectional area is pi d squared over 4. So the only graph that looks like a 1 over d squared shape would of course be graph D. So our answer to question 7 would be D. Okay, moving on to question 8. Again, it's sort of 50-50 as to how many people got this right. The first thing that's a little bit confusing is the fact that the variable resistor over here, it is actually not in line with the series resistor here. Now, normally when we draw circuits, we draw them so the resistor in series and then the voltmeter actually goes around the outside. but it actually makes no difference to the circuit at all. Okay, so once you've realised that, we're looking to find out what happens to the reading on the ammeter and the voltmeter when the resistance of our variable resistor is decreased. So if we've got our variable resistor and little resistor there, R, call it small r, in series with it, if the value of R goes down, then hopefully you can see, because those two resistors are in series, the current flowing through those resistors and hence through the ammeter will go up. Reduction in resistance will lead to an increase in current. So we're looking for answers A or B, and then we need to look at what happens to the potential difference across the variable resistor when its value decreases. Well, once again we've got a decrease in the value of R, which means as the charges pass through the resistor they lose less energy, so the potential difference across that resistor will decrease. So there's only one answer there, and that is answer B. Question 8, B.